Hello, I'm Peter Newman from AHRI, and I'd like to explain this week's edition of AHRI Insight to you. Now, we've previously reported in AHRI Insight of a population of crowsfoot grass from Malaysia that Adam Jalaluddin has studied. He's a PhD scholar at AHRI, and he found that this population of crowsfoot grass is resistant to glyphosate, paraquat and glufosinate. Now, today we're talking about the glyphosate resistance aspect of that and the mechanism of that resistance. So Adam has studied this glyphosate resistant population in more detail, and what he found was this: if we look at the dose response curve where we have percent survival of the crowsfoot grass here versus the glyphosate rate, his susceptible looked a little something like that, where at around about a litre per hectare of glyphosate he had pretty much 100% control. Now, he looked at some plants that had about 5-fold resistance, and their dose response curve looked a little like this, and when they looked at what resistance mechanism that had, it turned out that they had the 106 target site resistance mechanism. Now, there were some other plants in the population that were highly resistant, and their dose response curve looked like this. So complete survival, even at very high rates, out to 50 litres of glyphosate per hectare, which was the highest rate used in the trial, 57 litres in fact. Now, it turns out that these individuals were resistant by the TIPS mutation, which is a combination of the 102 plus the 106 target site resistance mutations. The TIPS mutation was first discovered by scientists, and that was one of the first transgenic glyphosate tolerant corn crops that was released in the 90s. Now, it's not really used anymore, this mutation, but it had never been found in nature until recently when Adam discovered this population of crowsfoot grass. So this is the first time the TIPS mutation has been found in nature, and it gave very high levels of resistance. There's a little bit of good news, and that is that these individuals here suffered a big fitness penalty. The TIPS mutation can give a significant fitness penalty, and the plants that were homozygous for the TIPS mutation had quite a significant fitness penalty. In a moment, if you'd like to listen on, I'll explain a little bit further about what the TIPS mutation actually is.